Sir,
Yes, Tumišo, how is it going that side?
doing fine, thanks.
Good, goodest. Okay, I believe you are able to see my screen. Are you?
Yes, I am.
Okay, then it's fine. I just checked on our last lesson, and I think we said we'll just have a look at some exam papers. So I've got an exam paper here, and I would like for us to brainstorm and see how we can answer this question. And then we will also compare with the memory check if what we have done, it is correct. And then if we manage to quickly finish it, then we will look for another question paper. Are you ready there on your side, Tumish?
Yes.
Okay, then it's fine. Question number 3, they want you to start on a new page. A small ball is dropped from a height of 2 meters and bounces a few times after landing on a cement floor. Ignore a fraction. The position time graph below. Non-Toronto scale represents the motion of the ball. When you look at that, Tumišo, do you have an idea of what's happening there?
Yes.
Are you sure?
I think so, yes.
Maybe just try to describe what's happening there by just looking at that graph. Try to just interpret or explain what you understand with what you are seeing there.
Okay, so the first time the ball is thrown from, I don't know, from a building maybe, or from the height of 2 meters, and then it takes 0.64 seconds to reach the cement floor. And then the second time, it's also dropped from a height of 1.85 meters, and then it takes 1.90 seconds to reach the floor. And then the third time, it's also dropped at a height of 1.2 meters. Yes, and then the time for the final, um, yeah, it's not given.
Okay, so the question is, what happens there? What's happening there?
I'm not sure, sir.
Okay, then it's fine. We will definitely need to interpret this. So it is not thrown, but it is dropped. Nay.
Yes, sir.
Very important, because if it's thrown, then it explains a complete different thing. But most importantly, it's like you are standing at the top at a height which is almost that of the door frame. You know the door frame, Tumish.
Yes.
Let's say, yes, this is the door. That door frame is almost, if not 2 meters. So it's like someone is standing there, and then what they do, it is to drop a ball. So when you drop a ball, Tumišo, from that initial height of 2 meters, that ball, it is going to then hit the ground. As soon as it hits the ground, after it will take a certain time to get to that floor. So according to that, they say it takes 0.6 seconds. Does it make sense, that part?
Yes, sir.
Okay, if it takes that to hit the floor. What do you think will happen after a tennis ball hits the floor? Will it break through the floor? Or what happens after it hits, or the first hit?
It jumps back up.
Yes, it jumps back up, but after hitting the floor, it doesn't instantly just go up, but it remains in contact with the floor just for a few seconds. This is what happens just for a few seconds. It's like it doesn't just hit and then same time it goes up. No, it remains in contact for few seconds, or for few mini seconds, and then afterwards it goes up. So that is what is happening there, Tumish.
Okay, sir.
Yes, I'm tempted to say something, but I don't think you will know what that is. I'll be happy if you can say you know what it is. But we used to call it a Sbindi Bindi. Do you know Sbindi Bindi, Tumish?
No, sir.
Hey,
I don't.
yeah, now I'm disappointed. It's like it is that a rubber tennis ball. It moves very fast. I don't know what it is in English, but it moves very fast, unlike tennis. You know, there's tennis, but there is another one we used to call it as Windy Wind, and it moves very fast. Are you sure you don't know what I'm talking about, Tumish?
I don't. I don't, but I do understand.
Yeah, so that one, it wouldn't take long to be in contact with the ground. A tennis ball, because it's a bit heavier and it's not that soft as compared to that other one. It will take some time to be in contact with the ground. But think of a basketball, for example. If it drops, because it is big, it's heavy, and it's not that soft, it will be in contact with the ground for just a few seconds, and then from there it will go up. So as it goes up, it doesn't go up to the original height. That is why it will just go up to that certain height. And what is that height? It could be whatever the height. So it's not like you drop it again, Tumiso, because you can see where you are. There's no way you can magically be there in the middle of the air and drop it again. Can you see?
I understand, sir.
Yeah, so now at a height of 1.8 seconds, so that means it goes high up to there. And then what happens? It therefore bounces back, and then it hits the ground. And what time is that? 1.9. 1.90. Then from there, it doesn't instantly bounce back, but after just a few seconds, that's when it does that. It won't reach maximum height, but this is 1 point, is that 1.97? Yes, then it goes back up to whatever the height, and that height now it is. Do you not regret regarding how you interpreted it, Tumish?
I do.
Hey, me too. On your behalf, I regret, honorable member. I regret, but it's fine. In that way, you will never interpret it incorrect. So can you see, it's a science which is physical. You can see what is happening there. I think you now have a better understanding, Timish, of what is happening there. Okay, then it's fine. I'm just going to remove that. Then let's see. Okay, there is the first question, which says, define the term free fall. That one is something that you must know, Timisho, but even if you don't state it now, it's fine, but I would like to just know if you know how to state it. Do you know?
Yes, I think so.
Okay, then it's fine. I don't want you to regret. We will just make sure that you know how to state it. As soon as we are done with this question, we'll just check the memo. If necessary, we'll take a screenshot, and then from there, you will just compare with what you know versus what they say in the memo. Then you make sure that when you go to an exam, you know how to state it. But what I'm mostly interested in is for us to do the calculations. 3.2, they say use the graph and determine the following. 3.2.1. Did you see what they said, Tumish? They said use the graph to determine, or use the graph and determine the first question. 3.2.1. They want you to determine the time that the ball is in contact with the floor before the first bounce. There is a question to me.
Okay, so I think we have to subtract the 0.6, the 0.64 from the 0.67 to get the time in which it was in contact with the floor before the first bounce. So 0.67 minus 0.64.
What will that be?
0.03.
Yes, 0.03. Then you must remember to say seconds. If you don't say seconds, you know it's wrong, Mos. Yes, okay. The time it takes the ball to reach its maximum height after the first bounce.
Its maximum height would be, I think, I'm not sure, sir, but 1.90 seconds, and then subtracted by the 0.67, I think.
1.90.
90.
Okay, and then
Subtracted by the 0.67.
so if you do that, you will get the time difference. You will get the time from there to there. That's what you will get. But what the question wants, let's see, it is the time it takes the ball to reach its maximum height after the first bounce. You know, the best way to go about this, Tumish, it is to say, which height are they talking about? Is it this height? Is it this height? Or is it that height? Because they're talking about maximum height. Is it height 1, height 2, or height 3?
It's height 1.
Height 1.
Yes, sir.
Wait. Read that statement again. Height 1, it's going to be 0. You know why 0? Because that's where it starts. But on the question, they are talking about the time it takes for the ball to reach its maximum height. This is the key word.
After the first bounce. So is it 2?
It has to be height 2 because this is where we are having the first bounce. And this is where we are having the second bounce.
Yes, sir.
Tumish, are you sure I'm not confusing you there, honorable member?
I'm not confused, sir.
So now you get it, nay?
Yes, I do.
So what the question wants, it is the time. So that means the time that they want, it is that time there. Do you agree?
Yes, sir.
So now the question will be, what will that time be? What you need to know is that it's time from 0 up to there. What will that time be? That's what they want you to use the graph and determine.
So we have to subtract 1. Okay. I'm not sure, sir.
Okay, so what you need to do, it is to say the time from 0 all the way up to that time plus that bit of time. Do you agree there?
Yes, sir.
Yes. What if you can find that time difference, then you divide it by 2. Then you know what that time is, what that time is. Then you can take this time, connect it with that time, and then it takes you there.
I understand, sir.
Because this is like when you are dealing with the functions, if you want to know the value for the distance, the length, or the midpoint of whatever parabola. Okay, so now try to calculate and see what that time should be.
I'm getting 1,29 seconds.
1,29 seconds.
Yes.
Okay, so you say, how did you work it out?
I said 1,90 minus 0,67, and then I got 1,23. I divided it by 2, and then I got 0,615. And then I added 0,67, and then I got 1,29 seconds.
Okay, now what I would like to confirm is this, Tumish, to say what you've just said. Does it make sense to you? Are you sure you are not doing it because that's what I said, it is the way to do it?
Oh, sir, I understand.
Now you get it, ne?
Yes.
Okay, that's good. Now 3.2.3, they say the speed at which the ball leaves the floor at the first bounce. Do you understand that question, Mara Tumish?
The speed, the velocity. Are we calculating? Are we supposed to calculate the velocity?
Speed and velocity, one and the same thing.
Yes, sir, I do understand.
Maybe explain to me what exactly they want you to do there, Tumish.
Okay, sir, they want me to calculate the speed at which the ball leaves at the first bounce. So they want me to calculate the speed at which the ball leaves the cement floor after the maximum height, I think.
Yes. I think what you are saying is what I'm thinking. You may just be failing to describe it, but it's like they are saying they want the velocity at that time of 0.67, isn't it?
Yes, sir.
Yes, they just want to know at what velocity is it leaving the floor. That is the first bounce. Okay, then it's fine. Quickly try to work it out. And then as soon as you are done, let me know. Then I will check what you've done, Tumish. And then we will therefore move on to that last question.
I'm done, sir.
Okay. How did you work it out?
I used the formula final velocity squared is equal to v initial squared plus 2 times acceleration delta y.
Okay.
And then for the initial velocity, I use 0.
Why 0?
So,
You say for the initial velocity used a 0.
yes, sir.
Okay, then I'm going to ask and say, what are you calculating again?
I'm calculating the final velocity.
How am I going to explain this one, Tumicho? Because V initial is actually what you are looking for, because they said the speed at which the ball leaves the floor at the first bounce. So this is what happens, Dimich. So you see here, because it is being dropped, maybe let me use this diagram. You see here, it is being dropped, its V initial is 0. Do you agree there, Dimish?
Yes, sir.
Then it hits the floor. Then it has a V final there. Can you see there, Dimish?
Yes, sir.
Then it's in contact with the floor for some time. And then now this becomes the new V initial as it leaves the ground. Can you see there, Dimish?
Yes, sir.
Then it's going to reach its V final, which is now 0. Can you see that, Mish?
Yes, sir.
Then on its way down, this V final, it therefore becomes its V initial, where when it hits the ground, this becomes its V final. Can you see that, Mish?
Yes, sir.
Okay, then it's in contact with the floor for some time until it leaves the ground for the second time, and that becomes its V initial. And then that becomes its V final, where on its way down, this instantly becomes its V initial, and that will be V final. Can you see there, Tumish?
Yes, sir.
So what I can tell you is that you need three things in order to calculate the fourth thing. So it looks like you will need to redo it again because you made V initial to be 0. Can you see it to make sure that V initial, definitely it can be 0, isn't it? And
Yes, sir.
also, V initial is what you are looking for. So that means your V initial has to be your unknown. Makes sense?
Yes, sir.
Okay, and it's fine. Quickly, you can try to redo it. And when you are done, let me know.
I'm done, sir.
Okay. Okay. How did you work it out? When they
Okay, I said the final velocity at its maximum height is 0. So I substituted 0 on the final velocity, and then I substituted acceleration as a negative 9.8. And then I also substituted the delta y, the maximum height, which is 1.85.
okay.
From there,
And then
okay, my initial velocity was 6.02 meters per second.
You mean that's what the answer, that's the answer that you calculated?
Yes, sir.
Oh, okay, you say it's a, what did you say? 1 comma?
6.02 meters per second.
6.02 meters per second.
Yes.
Okay, then it's fine. So now they say the time t indicated on the graph. So it looks like that is the time there that they want you to calculate. What will that time be to me? Do you have an idea of what they are looking for on that one, Tumish?
I know that they're looking for the total time, but I don't know how to calculate it.
You know, my advice on this one, Tumish, is to say, how about you focus on finding this? How about you focus on finding that time it takes for it to reach that maximum height? You know what you're going to do if you find that time, Tumish?
Yes, sir.
Because it is going to be the same time as that. Then you can just connect it with that time, then you will know the total. Make sense?
Yes, sir.
So what I've said, is it enough for you to get started, Tumish? Or you've got no idea of where to start?
I don't know where to start.
Okay, so it's like if we have that being the height, we also have G. What other thing can we have? V final, we also have V final. So we have three things. Why not using those three things to calculate that time? If we get that time to be 2 seconds, then it means also here is 2 seconds, because time for it to go up will be equals to time for it to come down. Do you agree?
Yes, sir.
Yes, then you will have time, which is going to be 4 seconds. Then you plus it with all that time. Then it will tell you that from 0 at that plus 4, it will be that total time there. Am I losing you there, Tumish?
Yes, sir.
Yes, meaning you are not yet confident. You still don't have an idea of where to start, isn't it?
Yes, sir.
Okay. So from the formula, from the list of the formula, we just need three things, isn't it?
Yes, sir.
So we do have the height, we do have V final, which is 0 meters per second. This one, it doesn't change. Do you agree there, Tumish?
Yes, sir.
Yes, then we can use that information to calculate the time it takes for it to reach its maximum height. So if we find that time to be 2, then it means we will know what that time is. Do you agree there, Tumish?
Yes, sir.
Yes, then if we know that it takes 2 seconds, then it means even the time for it to come down will be 2 seconds. Can you see?
Yes, sir.
Then if we have that time being 4 seconds as total, will it not mean it will take 0, 0.671, 1.97 plus 4 to get to that stage?
It does, sir.
Are you sure?
Yes, sir.
Okay, then it's fine. So you can quickly try to work it out and then let me know when you get the answer. Then you will explain how you've worked it out.
Okay, sir. So for the initial velocity, do I substitute the answer that I got from the previous answer?
Uh, no, the initial velocity will always change. The initial velocity will always change. So isn't there a formula that you can use which does not need initial velocity?
No, sir.
It must be there. It must be there. If it is not there, then it means you might need to first start with initial velocity. Then after knowing the initial velocity, then you do further calculations. But what I've always known, Tumish, is that you just need three things, then you calculate the fourth thing. If the fourth thing cannot be calculated from just one formula, then you might need to use one formula in order to find the other, and then you do further calculation. But let's see. Okay, it looks like there. So that means you might need to first find the initial velocity there, diminish. Can you see?
Yes, sir.
Yes, then it means you will need to use one of the formulas to find initial velocity. Once you have it, then you will use another formula. So that's what happens. In case if you get stuck like that, just be aware that sometimes you use two formulas in the same question. How will you know? The marks allocated to that question will be obvious that you need to do more work. Makes sense.
Yes, sir.
Yes.
Mm-mm. I'm done, sir.
Okay. How did you work it out?
I used v final squared is equal to v initial squared plus 2a delta y to get the initial velocity, which I got
Okay.
as 4.85 meters per second.
Mhm.
And then I substituted into the v final is equal to v initial plus acceleration changing time formula.
Mhm.
I solved for the changing time, which I got as 0.49 seconds. And then I times it by 2. And then I added it to the 1.97 seconds, which I got as the total changing time as 2.96 seconds.
Okay, let me write it down. S 2.96 seconds. Okay, so before we check the memo, would you say all that we've done makes sense to me? Because I did notice you had some struggles with this question that has, or that starts with the graph. But did you fully understand?
Yes, I did.
Okay, then it's fine. I think what I want us to do now, it is to just check the memory. Let's see. Okay, the first one you said 0.03 seconds. Yes. And the second one 0.62. Hmm?
It's the second one is 1.929, 1.29.
1.929. Can you see on the memo there what they got?
1.29, 1.29. Yeah, it's not.
Let's not make sure.
Mm.
So, okay. Let's see. What did the question want? They wanted the time it takes the ball to reach its maximum height. Let's see. The time it takes the ball to reach its maximum height after the first bounce. Okay, okay, okay. It looks like our interpretation was wrong on that one. The time it takes the ball to reach its maximum height after the first bounce. So that means after the first bounce, how long did it take for it to reach that? Can you see there, Tumišo?
Yes.
It looks like they just wanted that time, not necessarily the total time it takes to reach its maximum, to reach its maximum second, to reach its second maximum height. It's not that total time from there, but it is from the first bounce. How long does it take to reach that? So that is why it is just that time they need. It looks like yes, because they got the time difference, then they divided it by 2.
Mm.
Can you see what happened there, Tumišo?
Yes, sir.
Okay, and then moving on to, okay, that one, it looks like you got it correct. Can you see there, it's 6.08.
Yes, sir.
Yes, it looks like it's something that has to do with the roundings. Okay, 2.96. Let's see if you've done it correctly. The initial 2.96. Yes. Can you see that one? You've worked it out correctly, Tumišo. So they're just giving many options in which it can be worked out. But Can you see that you did manage to work it out?
Yes, sir.
Okay, then it's fine. So now, maybe very quickly, let's check if we can squeeze in the last question there. Maybe something that you might need to expect in May, June. And May, June, what are we having there? Maybe this is what we are having. Okay. I think, okay, let's see there, Tumišo. We've got question number 3. They want you to start on a new page, and they say a ball is thrown vertically upwards with a velocity v from the edge of a roof of 40-meter tall building. The ball takes 1.53 seconds to reach its maximum height. Ignore air resistance. Again, they want you to define free fall. Can you see, Tumišo, that very much important for you to know how to define that? 3.2, they want you to calculate the 3.2.1 magnitude of the velocity being the initial velocity of the ball. So on that one, Tumišo, do you have an idea of what they want you to do?
Yes, we can use the formula V final is equal to V initial plus acceleration change in time.
Okay, maybe very quickly work it out, and then we will check if the answer is correct in the end. You can quickly work it out on your side, and then let me know when you are done. Did you hear me on that one, Tumišo?
Yes, sir. So, sir, I got 15,0 meters per second.
15,0.
15,0.
15,0 seconds. Okay. Which is just 15 seconds. What did you calculate? Was it the time that you calculated?
No, I calculated the initial velocity. Meters per second. 15,0 meters per second.
Okay, meters per second. Okay. Now they say maximum height reached by the ball above the edge of the roof. Okay, there is another question. Quickly, can you work it out?
Okay, so I got 11,48
You got 11,48. What is
meters.
okay? Okay, it's fine. But which formula did you use and what information did you substitute with?
I used final velocity squared is equal to the initial squared plus 2 times acceleration times delta y. And then I calculated for
Well,
delta y.
okay. Or V final, what did you substitute with?
0.
Okay, and then this V initial in 3.2.1. Eh?
Yes.
Okay, okay. Now calculate the, okay, no, we are done with that one. So now they're talking about you having to take the edge of the roof as reference point. They want you to determine the position of the ball relative to the edge of the roof after 4 seconds. You sound like you are done, Tumišo. What did you get for that one?
I'm not done, sir.
Are you still thinking
I'm not
about
done.
it or what's happening?
I'm calculating.
Okay, give it a try, see how far you can go, and then let me know when you are done.
Okay, so I got negative 18,4 meters.
Negative 18,4 meters.
Yes, sir.
Okay, then it's fine. So now 3.4, they say, will any of the answers to question 3.2 and question 3.3 change if the height of the building is 30 meters? Yes, if the
No,
height of the building is no longer that, but is that. Okay, why no?
because the height of the building is irrelevant to the calculations. We haven't used the height.
Yeah, so it's more like the what is it? The initial velocity and the maximum height reached. It's independent of the height of the building. It doesn't matter whether you are high up or wherever you are. Whatever that happens is dependent on its V initial. So that means how long it takes to reach its maximum height and how high it gets. All of that is dependent on its V initial and not necessarily its position. Yes, I agree with the no there. Okay, then it's fine. Tumišo, Let us now try to check on the memo what they are saying there. Where is the memo? Let's see what you have done. Okay, that one is that. 14.599, which is your 15 there. Yes. Next question. 11.47. Okay. Okay. Let's 18.4. Okay. 18.4. So that means the negative that you got, it simply means it is below that building. Makes sense there, Tumish?
Yes, sir.
Okay, and then that last one, you said no, yes. The motion of the ball is only dependent on its initial velocity. Yes. Okay, Tumish, on my side, I'm happy with what we have covered in today's lesson. I'm not sure on your side in terms of having any other questions, or have you got your eyes opened after these two questions, Dinesh?
Yes, sir. I have.
Yes, 100%. Okay. I think we might need to leave it here, Dinesh, as I prepare for my next lesson, unless if you've got any questions for me.
No, sir, I don't. I don't have any
Okay.
questions.
Until we meet again.
Sharp, sir.
Okay, bye.